there, which is kind of nice. There's also a lot of good venues around there, hotels, so it should be pretty easy to get to. So the new dates would be May 11th through the 13th. Other thing going on right now is, if you're not familiar with it, the Sans Holiday Hack Challenge. There's several people in the room. Raise their hands if you're playing it. Talk to them. Get interested. It's a fun CTF put on by Sans. Otherwise, I don't have any other big announcements. Anybody have anything in the crowd? Nothing? All right. Let's just see if our video's about ready.
We're good.
We're good?
We're live.
Oh, we're live. Oh, just kidding.
He's on the internet right now.
You're on the internet. How's that feel?
It's interesting.
Good. All right, we'll start this off. Covert exfiltration by Lucas.
Thank you. Yeah, so they asked me to come up with a title for this, and I picked covert exfiltration because it kind of fits. It's not 100% what it is, so hopefully it's as exciting as it sounded. This is a project I've been working on because most projects I work on start with a phrase, I wonder if I could do blah. And in this case it was hiding data inside packet headers. And I also have a tendency to not research if other people have done things before I start projects. So after being most of the way through the project, I found out that some people have done similar things before. You can hide data in packet filters, but packet headers, but I already figured out how to do it, so I didn't really care. So basically, I just wanted to see if you could do it, and this is what I came up with. And since this is all about exfiltrating, I already went through the exploitation phase of this for the speed of the demo. So, and I'm using Meterpreter, which is kind of a bad example because it has a feature where you can steal documents that's encrypted. But just to make this simple, that way I can use a PowerShell function and it'll be a little faster. So this is our exploited machine that we got into. This is the directory of the C drive, and you might notice whoever owns this computer is not too smart because they have a document called user list on the C drive, as well as a copy of my resume in PDF and Word doc. So we're going to go ahead and try to steal that. So the first step is setting up the listener, which I called exfil client, and then we entered the IP address of the system that we're going to be stealing stuff from, and that'll just run. And this side we're going to use a PowerShell function. We're going to start with the user list. Of course, I got the name wrong. Capital E. Nope.
You have to call it as PS1.
Maybe.
Getting sacrificed.
Of all things, forget the name of the function. forgot to import it.
Oh, you have a typo.
Where? Oh.
Roar.
Yeah. Thank you. There it is. Alright, so if we look, created 3 files called exfil file, and then exfil file ASCII and exfil file hex. ASCII and hex is just a hexadecimal dump of the contents of the file, and then once it translated to ASCII. That was mainly for debugging purposes. I need to leave this open. So now, if we have exfil file, we can take a look at it, see what we got. And that's his user list that he stored on the hard drive. Exact copy. Alright, so now if we run the client again, this time we're going to go for the PDF. See if we can get that. So I'm kind of curious as to why this guy has my resume. Alright, now this time the PowerShell function is actually going to time out because it takes so long to send it, because the PDF takes a long time to do it. So while that's running, I wanted to show you a packet capture I did of stealing the PDF one time. Just kind of give you an overview of how this is working. So I set it to set the time to live flag of the IP header as the actual number of each byte of the contents of the document. That way, the packet will still send, but it's containing all of the data in a place someone wouldn't normally think to look. I read online other people have used a couple other headers or header areas, including like SYN flags and that kind of thing. I'm trying to grab one of the red ones. Alright. One of the problems that I have noticed with this, because this isn't foolproof, is in some cases it's really, really low. Like that one, the byte is 2. And on a very largely congested network, that might be a problem. You might lose some of the packets, and then in that case, the file's going to end up corrupted. So that's one of the issues. Another one, if you may have noticed, there's a lot of packets. In order to send a PDF, it's about 260,000 packets approximately. And that's a small one. So obviously from a security point of view, it'd be pretty easy to find. So it's not exactly covert, and that's why the title's a little misleading. It's because 260,000 packets is going to attract some attention. And then one issue I had to resolve was sometimes files have a lot of null values in them, and you can't have a time to live of null or 0. It doesn't really like that. So that one I worked around by using an alternate port and a different number that it then translates into 0 on the Kali machine. So it ran. So we're going to take a look at this one. In this case, you have to rename the file to a PDF so that it'll know that it's a PDF file. So I'm just going to call it resume. And take a look at that one. And there it is. a complete copy of the resume. I tested this with Word documents as well, and it works. As a matter of fact, I ran a checksum against the captured Word file, and it was the exact same. Hash came out equal. But for some reason, Microsoft Word wouldn't open it. It threw an error, and I haven't figured out exactly why it's doing that, so that's another thing to work on. But it was a fun project. Spent a lot of time, a lot of headaches, and it turned out to be, it shouldn't have been as hard as it was, but that's just because I'm not that great at programming. But I set out to find if you could smuggle a document in IP headers, and I found out that you can. So it's a lot of fun, and yeah, that's pretty much all I have. Any questions?
Was that UDP?
Yeah.
And can you do it with TCP as well?
I tried it, but since you're sending it from a Windows machine, it keeps expecting to make a connection, and it errors out a lot. So I'd like to try different protocols in the future. I was thinking doing HTTP so I can make it look like it's actual back and forth web traffic, but haven't got to that yet.
Do you have your code anywhere, like online?
I haven't posted it yet because I don't even have a GitHub account yet, but I'm planning to do that soon, and it'll probably go up there.
Do any of our firewall vendors in the room think that their product would catch it?
It depends on your policy for allowing UDP.
Let's
Yeah, allowed by default, with a default deny, which a lot of the accounts that I've witnessed have.
I'm talking
That
about
likely wouldn't get through at all.
I'm
until
talking
you
about
start doing
anomaly.
the TCP.
anomaly kind of stuff.
So if it doesn't know what the traffic is, you can get up to 35 packets before it will kill you.
Yeah.
A certain vendor that I know.
Hypothetically.
Or that rate alone would probably trigger something based on
You think so?
260,000 in a few seconds with flood protection applied to it.
I was gonna say it kind of looks like a DDoS. I mean, just
Yeah.
looking at it.
Yeah, it moves pretty quick.
If you use FQDN, it's unknown. Block unknown and try to kill it before it starts.
That's one way to find out for sure.
There is. Yeah.
Some firewall vendors will still anonymize the TTL as well, so that they can, because it used to be that you could do fingerprinting based on the TTL.
Right.
Yeah, and that's kind of another thing too is in normal traffic the TTL doesn't change. Generally in a stream, it's usually the same number, so it's kind of another red flag that you might notice looking at the network traffic.
So does your first packet basically tell the receiving end how many, how many hops there are between them, so that it knows what the TTL should be degraded to?
No.
Yeah, if you try that on a routed network, you get different data.
Yeah, so you get a
It
lot.
almost always starts at 255 and goes down from there.
Yeah, but an A would be something different if you had 3 hops.
Yeah,
or
that'd be
7 hops.
shifted. The number of hops.
Okay.
Yeah, right now I've only tested it on where they're like both on the same LAN, so I like just got it to work a week and a half ago, so it's a miracle that we have this.
It's good stuff.
Yeah, cool.
Next up is a toss-up between James and Kate. Who wants to go next? James it is!
Fight it out.
James will be talking on how not to design a web app. By James.
You know, it was messed up before. Cool. So my talk is how not to build a web app, the story of learning through failure. Basically, I'm going to go through 3 examples of projects I've done while coding through college, and some of the things I've learned about security the hard way. So, all right. So yeah, what's this? Basically, what I just said. I'll talk about how to fix the vulnerabilities that I found. A lot of the stuff was somebody coming to me and saying like, "Hey, so this is an issue. Here's how I did it," and then the fastest way I could fix it without still being in trouble. Yeah, so here's a couple of examples. So the first one was a club website I did for one of the groups that I was with. basically, I was coding late at night. This was after work, after classes, just doing things from like 10 until 4 in the morning. Because of that, when it was late, I'm just like, okay, just get it done. That was the mindset I was in. I wasn't really thinking about testing first or doing anything with security controls. We had a function that had to get done, and I just wanted to make it work. So that was the idea. Only took a couple weeks to get it done, and before the next club meeting, I think, so like at least a month, I got it working where it seemed acceptable. Only issue was it was a really bad SQL query. So I'm sure you can guess the basic secure coding practice that I forgot was parameterized inputs. All of the strings that I was working on was basically, here's a string for the SQL query and then adding the input based on whatever the user typed in. Didn't do any validation, do anything fancy. All it did was when it was supposed to work was that the query was used to track people's attendance. You type in your email, if you existed, it would say, okay, this person's, it would increment their attendance count. Otherwise, it would tell you to create an account on the website. So, just track a new email address. So it worked if you did it correctly, but if you try to modify that input at all, if you just put in semicolon, put in your own SQL if you knew what it was, you could completely change the outcome. And basically, instead of alerting saying like, oh, you've attended this meeting or redirecting you to the account page, that pop-up box would just dump out the entire user list and show you all the emails for the club. So that was a good one. So parameterize the inputs. That seems like the straightaway answer for fixing this. I knew about it at the time. Basically, I think like the next meeting after that, I was giving a talk about the broken web app and said, oh yeah, SQL injection is bad. And that's when people called me out on this. But anyway, so basically, in order to fix this, instead of doing parameterized parameterized inputs, I just used input validation instead. Basically, making it match a regex validation. If it wasn't specifically an email address, I just completely forgot about the input and tell the user to try again. So if there were other people at the club just trying to mess with my account as they were signing in to get attendance, it would just ignore them. So it stopped people from messing with me, at least, and that's the important part. The second example was a website with meeting information. So don't want to get more specific just because this was for a friend of mine for the stuff that they were doing. But it was basically a website that allowed members to upload meeting minutes, documentation, rules and stuff about how their organization was supposed to work. So users were able to log in, see the latest documents that were on the website, or if they were the admin, they could upload new information. Right? So the big issue with that is the fact that we just were doing file uploads in the first place. It's just a website, you went and uploaded whatever you want if you were the admin. So I wasn't validating anything. The file type, the content, you could have uploaded a virus, somebody could have looked at it, they could have downloaded it, sent it to their mom. It doesn't matter. So I think the only saving grace that I had was the fact that you had to be authenticated to upload anything. Probably not the most secure because, again, it was fast SQL. But anyway, you had to be an admin to do it. So what I should have done to fix this, there are ways to validate file security. One being that you can check the name of the extension. So if you're uploading Word documents for meeting minutes, it shouldn't be .exe or something. Shouldn't be a bash script, something like that. Another option is to check the magic number of the file that confirms the file type is actually what you said it is. Third option would be to send it to VirusTold or something and see if it's actually malicious or not. And then if it is malicious, get rid of it. Otherwise, deal with it. So yeah, and finally you could cough up some cache or an AV scanner, but for a little project for my friend, I'm not going that far. Okay, so going through this real fast, but sales website, this is probably the last example and definitely the most embarrassing. So I created a website that was just hosting, to be really vague, objects for sale, right? Don't want to go into this too much. So when you wanted to add a new object, basically you just upload an image, like a description of what it was, you'd have a title, and then a description. I'm selling it for this much, it's got these features. You go for that, right? So with a site like that, what could really go wrong, right? You're uploading another file, that image, right? You're just sending up something there, and obviously we know I'm really good at file validation already. And on top of that, you're saving a giant text box that's going to be displayed on another page, right? So, oh man, don't want to talk about this. All right, so basically what this meant was just everything was injectable. Not just cross-site scripting or SQL injection. The thing that hit me the hardest with this website was you could do HTML injection, and you could somehow upload your own HTML pages and basically make your own content on this website. The way I found this was Google actually told me when you searched for this website, it would tell you this site may have been hacked. Didn't figure out how that happened until I went into the server directory, started looking at all the files, and there were HTML files that I didn't know existed. And when I started looking at the content, there were adult content web pages that weren't supposed to be on a sales website. So luckily you had to actually get around headers to see these web pages. It wasn't just showing up on the website, otherwise I could have gotten in a lot of trouble for not securing this faster. So really glad this is on the internet right now. Anyway, so what I've learned is always plan your security controls before starting development. This saves you from getting in a lot of trouble. Testing is important, right? So don't just make sure it works the way you expect it to. Try to break it before somebody else does. And that's basically what I just said. Hack yourself before you get hacked. So do a lot of security testing. Do it yourself. Don't let other people hack you, because it's a lot less embarrassing when you figure out that there's HTML injection yourself and not when somebody else starts using your server for their own purposes. So yeah, that's me brushing through a quick slide. Any questions about the examples or anything?
How long was it up before you realized?
That last one, honestly, I don't know. I finished the project for a while, and then I went just searched for it because I couldn't remember the URL, and it said your site may have been hacked. So as soon as I saw that, I went in and tried to fix it immediately. So yeah.
Are any of those still up?
One of them. Yeah, I'm not going to tell you which one because but yeah.
Clearly he trusts his audience.
Yes, yeah. So one of them is still up. I've put in some of the security controls since then, so it's not as vulnerable. But yeah, that's why I'm trying to be vague, because yeah.
You don't want any free testing?
No, I don't want any more free testing. So, but yeah, that's it. Thank you guys.
And our next speaker is Kate. You too can tackle PCAPs.
Is that what I named it? Alright.
That's what you gave me.
You're not gonna learn it today. Just says you can do it. I didn't say in any time frame. It's just gonna take me 10 minutes to tell you you can do it.
It says you can
If it
tackle
takes
it.
10 minutes to tell you you can do it, it might be a little...
It might be a little longer than that. Yeah, step 1, learn PCAP. Step 2, profit. Alright, how does this work? Does it just do it?
Plug it in.
Plug it in and go. Come on, this is technology.
Plug and play. There we go.
Good luck with that one. Alright, well, if it lets me log in. Alright, cool.
Hooray.
We'll start with the takeaways. No, I just named it there. You too can PCAP. My name is Ida, and I'm going to kind of just talk about that. First of all, this is totally just a shameless plug. You can, that's supposed to say SEC 503, but I just encourage people to go learn about PCAPs and intrusion detection and go ahead and take SEC 503. And you can check out my codes. We're going to go over here shortly on GitHub at that URL. First, I want to talk about I just kind of threw it together pretty quickly in one evening, and I just put my Twitter thing up, and then a bunch of people started talking about it, and I was like, oh, that's really nice of them. And then they started contributing too. So I'm going to say it's really awesome to be able to put your code on GitHub so that people can look at it, add stuff, give you ideas, build off of it, and make your code better, because I could not have done what it ended up being by myself. So I'm going to kind of go over the code, which you might not be able to read very well, but basically just takes 2 arguments, and one of them doesn't work today. The first one is just the file name of the PCAP that you make your own PCAP and then you pass it over to it. The second one is this header information, and in SANS with all of the, they give you little cheat cheats for if you want to learn how to like look at the header and understand what the PCAP or what hex you're looking at actually is. So this actually, I drew out the little diagrams we'll see shortly. They kind of look like this. There's a little table that will show you what the offset is so that you can kind of map it out yourself. So you can turn that on or off if you think you've got it and you don't need this help, you can just turn it off. So similarly for TCP and UDP, and I won't go through all of them, but they all look like this. So these questions are very similar to the questions that were asked on the exam. So it kind of gives you, like you're just going to quiz yourself on looking through this hex and figuring it out yourself. And it does the math for you so that you don't have to code that piece in. I use Scapy to do that. And it also includes, like, if you want to just add all the flags here, it'll figure out which flags are actually being set. So when it asks you in the quiz, it already knows what the answer is. So, it just kind of helps out. And then, for some input validation, which we just learned all about, if it's not an actual number, it will take care of that. And then at the end, whenever you feel like quitting, it will display what your score is. So I just grabbed a random PCAP and, hey, I'm just going to do this thing. And started going through it. So you can see at the top, I'm just calling the file with the file name of my sample PCAP. And here is the header that will explain what you need to look for when you're trying to figure out the answer to the question. So given the IP datagram, what is the decimal length? You can see total length is the little side there, so you can count version, and you just keep going. And these two pieces are for the total length. So you take the 3 multiplied by 16 is?
Too much math.
I think it's 48.
It is.
Okay, good. It's 48 plus 8 is 56. I know. Wake up, guys. Come on. All right. And you would be correct if you entered it. 56. And it would tell you so. It's correct. Good job, guys. The next question is, what protocol is in use? And actually, this code will determine, like, if you've got some TCP or UDP or whatever the PCAP that you give it. Based off of the information in the PCAP, it's going to ask you certain questions. So what protocol is in use? And then we can find this little field there is protocol, which is over here, if you count it out, which I will not. And 11 hex is what in decimal? 17. Anybody know what protocol 17 is? UDP, all right. Ta-da, you are correct. So the next one, destination IP. You can see that's way down here, and it sounds like a lot of work. So I answered LOL, as I do, which is incorrect. And it will it will figure out based off of, Scapy has the ability to do that. It'll figure out what IP it actually was and give you the correct answer. So then you would continue on to the next question. What is the UDP destination port? And it will go through each of the packets in the PCAP as it applies. So in this, what is a UDP destination port? So those two right here. 35, which is 53, and everybody knows what 53 is. DNS, that's right. So if you get a question like this, given the IP datagram, what is a decimal length, and you get that spew of hex because it's ugly, you decide to quit. It'll give you your final score, and it'll actually, Justin did this, the score breakdown, so it'll tell you kind of where your weak points are in the, quiz portion of it.
You actually get a negative point for the wrong answer.
If you
Am I
stink.
interpreting that right?
Yeah, I got a negative point on the destination IP, right? I didn't get any destination IP questions correctly. And it, it just didn't count the decimal length one. Although, you know what? This looks like, no, it's the first question, so we're good still. That should be right. If it's not, whatever. So yeah, I basically just want to show the code so that everybody else can go home and practice on their PCAPs if they feel like it. They can also contribute to the stuff if they find they want to add questions or look through it or, basically anything. And then it kind of encourages other people that if you don't want to have someone else quiz you or you don't want to deal with trying to learn something, write your own, right? Steal the code from my GitHub and just make your own quiz and just kind of, play with it, I guess. And that's all I had. So if anybody has questions. Yes.
When we last talked about this, you said that whenever PCAP it loads, it basically goes through packet by packet.
Yes.
Have you figured out how to randomize that yet so you can keep quizzing yourself on the same PCAP without having the exact same questions?
I have not randomized that yet, but I forgot to write that down when we talked about it. So,
That's a good idea.
so I mean, it's something.
Feature request.
I say we can pull up the code. I've got a whole bunch of comments on things of like to do this, could add this here, all this
Submit
other
a feature
stuff.
request to the GitHub repo.
Yeah, if you would add me a feature request, that would be fantastic. And you know, if you feel like solving the problem yourself, you can go ahead and get a pull request too.
Are you using this in your class?
I'm not teaching any networking classes this semester. I would have when I was teaching the IDS class though, because I was making them learn this anyway. So I would use it. And it's, someone on Twitter actually said they were giving it to their SOC analysts to practice around. So I thought that was really cool.
So are you using Scavy libraries to pull the header information?
Yes, I am.
Okay. So that's not something you wrote?
No. I'm just utilizing Scapy, so it's doing all of the actual figuring it out. So you manually figure it out and answer the question.
So if I feed a file, it's not gonna.
No, I probably should do some file input validation as well.
Well, it'd only affect his machine.
Yeah, that's true.
He can hack himself.
Yeah, you can hack yourself all day long. I don't really care. Anything else? Anyone gonna try it? Anyone gonna play and learn PCAP? Anybody interested in learning PCAPs? Okay, cool. Well, I can show you. Yeah, that's it. You already know where it's at on GitHub. If you have any questions using it or whatever, just let me know.
So not saying it's not interesting, but what would be more interesting would be kind of a TCP dump filter quiz.
I could add filters to it.
I think would be a very cool thing.
Yeah.
That would be cool, actually.
Would you do like a Berkeley packet filter type of?
Yeah.
Okay. Yeah, I could add that. So I got two things. I need to write these down.
Submit it to GitHub.
Yeah, submit it.
All right.
Cool.
In my free time.
There's nothing else I'm done. So, all right.
You were done.
And I'm not speaker, Sam.
Oh, my foot's asleep too.
Crafting and convincing spearfish. Now, this talk may or may not have been pushed a little bit by Daniel.
A little bit? A little bit.
I mean, we may have ambushed.
Like the fact that up until 2 minutes ago I was still grubbing on you about not doing it.
Yes.
Yeah.
Practice does make perfect.
Yeah, but if you practice failing all the time.
You only get better.
I didn't hear him what?
Based upon the truffles in my bag, you can do no more.
But I have not failed at making truffles yet, so that's not a fair argument.
Well, you always got that in your back pocket.
Yeah. No truffles in my back pocket. No truffles in the back pocket, no. Okay, so in a recent assignment I had, unspecifically from who, I was taught how to do spear fishing. A little bit about me. My name's Samantha Paquette. I had the name for 2 months now. I'm a student at Baker College. I'm married, and I work at Consumers Energy. On the agenda tonight, I'm going to teach you the purpose of phishing, how and where to collect information on targets, what to use and what not to use, how to construct an email, an example email, and how to protect yourself, and then questions. So the purpose of phishing emails is to collect personal financial information. Hackers will use this to either A, take your money, or to convince you to give them your money. To collect usernames and passwords. Usernames and passwords could be anything from your Facebook, Twitter accounts to your financial information accounts. I have had or have heard recently where username and passwords were taken for financial information accounts and money was wired. Break through your computer's defense to get information on you to maybe collect, either to, encrypt your device or to collect ransom or to get information to use against you, and again to encrypt your device for ransom. How Phishermen collect information: social media sites such as Facebook, LinkedIn, Google search, Twitter, or the white pages. I used all of these and more in my phishing campaign. I actually found a lot more on Google search than I thought I would. When I phished myself, I actually didn't find as much as I thought I would. I'm a little more locked down than I thought. And this is what we found. All these images, they're blurred out because I didn't really want to post people's information on my video. But these are all things from Samantha Paquette or Sam Paquette And the things I learned is that I'm 11 weeks pregnant. Information to me. I sell makeup. This is new because I can't do my own makeup very well. I own a bird. I speak multiple languages. I work at Dunkin' Donuts. I'm male, but I'm still 11 weeks pregnant. And I have 17 people endorsing me saying that I make a good sandwich. Let's hope one of them is my husband. And the last piece of information I found was that on my tombstone, I would like it to say, Samantha Paquette, this female dog, loves Pokemon and Long Johns. If I happen to die, please, and Spanx. That was my
That was
favorite.
actually you, though, right?
No, that wasn't me. But she looked a lot like me. So, learning from the things I found, since I'm not pregnant, I'm not male, and I don't own a bird, I learned to verify. So use the knowledge that you do know to find knowledge that you don't know. If you're trying to fish me specifically, you know that I live in the Jackson area, you know where I work, you know I'm female. I hope you know that I'm not pregnant, unless I don't know that I'm pregnant. Things like that. So you know what I look like, you know what I do, use that information to find more information on me. Dig into accounts before assuming you have the right person. So instead of looking at the profile image saying, that looks like Sam, there are people who create accounts that using other people's information to try to get information from you. So it could be an account that somebody else created in my face, in my name. Dig in the account. If they have no recent history, nothing back past 2016, assume that it's not a proper account or that it's not me on the account. Cross-reference. By cross-reference, I mean that if my Facebook image looks like this and my Twitter image looks like this, you can, 1, assume you have the right profile, and 2, assume I have weird-looking friends. So, true information we did find, and I did use fake accounts. I created a fake Facebook and a fake Twitter account so that I could look at only what was public on my profile. So my maiden name is Rona. I'm married to Mark Paquette. I study at Baker College. I did find my employment and 2 of my previous employers. The things that I liked, such as sports teams, video games, TV shows. My pets, discovered that I have 2 dogs, no birds. The music I listen to, and the places I frequently visit, such as restaurants, wineries, shopping malls, things like that. So what to do with this information? You can choose a topic that you see that I post most frequently about. I posted most frequently about my dogs. I did discover that my entire Twitter was not locked down, so I changed that. None of that was privatized. So choose a topic that your subject seems to be most interested about, whether it be, going to breweries or, playing a lot of video games, talking a lot about their pets, even, talking a lot about the places they shop or the things they like to shop for. There was a lot of subjects I had that talked a lot about what they like to shop for, and, where they shop, such as Amazon, Macy's, Target, things like that. Choose how to approach the topic. You can approach it as if you are a store trying to solicit information, a game relating to their favorite topic, whether it be a Facebook game. We all know there's Facebook games about pets, and I have actually played quite a few of them. Meetings. If you found a lot of information on somebody about where they work, you can post a phishing email saying that there's a meeting coming up that you'd like them to attend, or a training seminar you'd like them to attend, or order updates such as online orders with Amazon, Unique, online orders for Target, Walmart, and you can construct the email. Start with a welcoming message that pulls your target in. Something such as, hey, thanks for shopping with us, or we see you're interested in such and such. The subject should be appealing to the target, going back to choosing something that they post most frequently about. Include at least 1 phishing link or attachment. Well, if you don't include those, you're not actually phishing. So a lot of the campaign was phishing links because they're easy for people to click on. You can create an image and connect a link to the image, or create an attachment, saying that on the attachment is your coupon or things like that. You can finish with a sincere goodbye and sign the email from a convincing contact. The convincing contact is huge because if you sign it from Joe Schmo, the person's going to look at it and be like, well, that's not legitimate, so I'm going to assume this is phishing, especially if they're used to being fished upon. And then you send and wait. So I actually made this email related to the fact that I post a lot about my dogs. You can see at the beginning it greets them as a loyal customer. It's from PetSmart. These images are actually from PetSmart's current website. And I even took this is terms and conditions at the bottom here, copied right from the website onto the email. And it talks about the coupons that are in the email. So it looks more legitimate that they're tied together. And each one of the blue boxes has a link connected to it, taking you to a phished website. It's not a real website. But that's just an example of an email where it looks convincing. Doesn't mean anybody's going to click on it. I would probably click on the coupons because why not save money? And then, so how to protect yourself from these emails. Lock your account. Set everything as private, or everything that you can, if you'd like to be as private. I do choose to have my employer as public and that I'm married as public because you don't want random personal messages from guys. Keep your settings on private. So you can set actually where you don't have background searches on your Facebook page, which ties into location sharing. Actually, one time I had posted, I was in New York and Facebook signed me in Hong Kong because I do not have my location sharing on. So one, I thought it was kind of weird that I was in Hong Kong. My mom commented on it and asked me why I was there. But turn your location sharing off because if you are on vacation and you don't have somebody at your house and it shows that you're away on vacation, somebody could actually use that as information to break into your house. So outside of phishing emails, that's a self-protection issue. And keep your background searches off. So when I was actually shopping on Black Friday, I was at the mall. I had taken a selfie because I was looking fly. And my phone actually had said to me in my gallery where I see my images that it saw where I was at and asked me to post a picture where I was at because nobody had posted recent pictures. And I was like, well, one, I don't like the fact that you know that I took a picture. And two, I don't like the fact that you know where I'm at. So if you keep your background searches off, when you actually Google search an area, it can see pictures that people have taken in that area and pictures that people have posted in that area. So if you have the background searches off, that can protect you physically as well as in phishing. Is there any questions? No questions. This one's for Kyle.
Final talk, we're going to go radio silent here shortly, so anyone who's on the stream, thanks for watching. Bye.